homework or exercise. Okay, and before that we have solved similar numerical in our class, online class. I expect that everybody should have solved because on that day everybody know that they have understood the numerical and in this regard, so everybody have to solve this numerical. Okay. Anybody having problem? So anybody of you have got the solution so that he or she can present in nice manner so that our time will save. We will discuss the solution here only. Anybody of you have solved? Kunal? Hmm. Kunal was I think absent last time, correct? Anybody completed the solution in all respect so that he or she can present. Kunal, Suhas, anybody of you?
Yes,
Must
sir.
all done. Okay, who is Sachin or what? Sachin? Sachin
Swaz,
Siddharth?
Swaz.
Suhas, okay. So Suhas have solved?
Yes, sir.
Okay. Other than Suhas, who has solved? Suhas is always last time his solution only were discussed. Anybody other than Suhas? Gaurav, Kunal, Seneshwar, Ajit, Rishikesh Deshmukh. Kunal Shetty, yes sir. Kunal, have you solved? Or
Yes,
absent
sir.
last time? Last time absent.
Yes, sir. But solve.
Solved. Okay. So okay, good, good. So anybody other than Suhas, Kunal? Then okay, let Kunal you present. You can present your PDF. Kunal, can you present your PDF?
Sir, mobile the problem as well.
Well, Suhas, okay. Suhas, can you present? Suhas, okay. Otherwise, I will help to
Yes,
solve.
sir.
Suhas, can you present your PDF?
Yes, sir.
Okay. So that that should be visible to all. That care you take.
Screen is visible.
No, now, okay. Go on. Go on. Suhas. Voice, some background voice is there. Just take care. Okay. So all our friend, whether screen is visible, is screen visible to all. So you have to pin Suhas.
Visible, sir.
Visible to all. Okay. Okay. So numerical is like this. Okay. Here written numerical. Okay. So last time I have written what is required. So heat supplied. So heat supplied is equal to there are heat supplied. Oh, everybody, it is visible to all. Anybody having problem? Okay. So heat supplied. We have to go for three columns: heat supplied, heat utilized, and percentage utilization. Okay. So heat supplied is there MF into calorific value, but we are drawing the heat balance sheet on 1 kg of coal basis, and therefore it will be 1 into calorific value. Okay. And what is the calorific value is given? The calorific value is given as 33,000. Okay. So 33,000 into 1 will become, but sorry, it is a moisture is given. So moisture loss is there. It is 1 minus 0.0025. I think 2.5% moisture is given. So 1 minus 0.00 1.0025. Okay. And into calorific value is 33,000. Okay. And it will become, answer is coming as what? 32,175. So that much is the heat supplied to the boiler. Now in the heat utilized column, we have to write down the heat utilized. Okay. Heat utilized, always the first utilization is heat utilized to convert water into steam. And therefore, that we are denoting by Q, heat supplied by Qs. Okay. Here it will be Q is equal to Ms upon Mf into Hs minus Hw. But he Hs is equal to, as steam is wet, cause dryness fraction is given and it is less than 1. If the dryness fraction is given and if it is less than 1, then we have to consider that the steam is wet. And what is the equation to create the air enthalpy of steam? Hf is equal to, sorry, Hs is equal to Hf plus X into Hfg. And they have given the they have given the values of Hf and Hfg. So they have given the pressure. Am I right now? Kunal, okay. Pressure is given 10 bar, and at 10 bar pressure, we have to go for the steam table number 2. Okay, steam table we have to refer, and from that we have to calculate HF and HFG. And after solving it, he will get the answer that here HF plus XHFG. HF we have to record from that at 10 bar, HFG also at 10 bar, and X is given as 95. So from this we can get that HS is equal to 2675.82, and at the same time HW is equal to HF at feed water temperature. So table number 1 we have to refer, and temperature of feed water is given as, air temperature of feed water is given as 40 degrees Celsius. Okay, so 40 degrees Celsius, table number 1 we have to go for, because temperature we are knowing. And from this temperature, table number 1, 40 degrees Celsius temperature column, temperature column, we have to go for the value of 40 degrees Celsius temperature, and in that case HW is coming as 167.5. Okay, after putting these values, ms is equal to 1550 divided by 70 into hs minus, and mf is equal to 70, and hf and hg, sorry, hs and hw. Then we are getting amount of heat utilized to convert water into steam. So how much it is there? It is coming as, anybody?
19,708.22.
Okay, make some thing somewhat clear, was you can make it little bit. Okay, now it is clear. Now it was clear. Okay, so it was 19,708.22. Okay, then afterwards second utilization was there. It is losses will start. Okay, and in that case losses, first loss they have given. What is that given here?
Heat loss due to
Dry
dry
flue
flue
gases.
gases.
And what is the formula for that? What is the formula for that?
Q1 is equal to mg upon mf
mg
into cpg
mg upon
tg minus ta.
mg upon mf into cpg into tg minus ta. So that formula already we have covered. So that is nothing but what mg is given. Mg upon mf directly they have given. Okay, and what is that value? Mg upon mf value is there, I think 8.5.
8.5.
Okay, cpg is given as 1.005. Okay, and in that case here, here Tg is 350 minus Ta is equal to 30, and answer is coming as what? 2733.6. So this is mg upon mf into cpg into tj upon ta. Everybody getting answer, or anybody having different answer than his answer? Any other students can comment? Kunal, others? Chaneshwar, same. Okay. Nikita Power,
Yes, sir.
same. Good, good. Nikita Power, are you understanding now? Pramod Avlekar, same. Avlekar is no problem. Chaneshwar, no problem. Okay. Then Kunal is also getting same answer. Okay. Then heat loss due to conversion of water
In the fuel into
into
steam.
steam. That is moisture loss. What is that formula is there? Here it is MW, okay, into bracket
Six
2676
seven six
plus CPS into bracket
CPS.
T superheated minus 100 minus HW. But here this HW you have to take it as a at boiler room temperature,
Room temperature.
and there HW have to take it as a here feed water temperature. That care we have to take. And here it is equal to M is equal to 0.0025. 2% means MS is equal to, sorry, MW is equal to 0.025. HG is equal to 2676 plus CP is given as I think 2. Correct, na Kunal? Swas,
Yes, sir. Yes, sir.
2676 plus 2. Okay, into T soup means temperature of flue gas only. That is 350 minus 100 minus HW is a HF at
125.
here
It is
boiler
at
room
boiler
temperature.
room temperature.
Boiler room temperature is given as I think uh, okay. It is again table number one we have to refer. Temperature is knowing, and that temperature is boiler room temperature, and it is I think coming as
125.7.
125.7. It is a heat loss due to conversion of water moisture into steam. That steam is superheated steam because that moisture is burning in the combustion chamber itself. Okay. Then all other losses they are not given information. Only two losses: heat loss due to dry flue gases and heat loss due to moisture. Then heat loss due to, if all losses are completed, one loss always we have to take. That is heat loss due to radiation,
Radiation.
or it is also called as unaccounted heat loss. Okay. And heat loss due to radiation is equal to, how much it will be equal to, is equal to heat supplied QS. Okay, minus summation minus in bracket sum of q plus q1 plus q2, and it is coming as 906, sorry,
56.
9656.90. Correct, na?
Yes, sir.
9656.93. Am I right, na?
Yes, sir. Yes, sir.
9656.93. All are getting same answers like previously we replied. Chaneshwar, okay, same. Kunal, same. Okay. Anybody getting different answers? Okay. So shall I consider this as a correct answer? Because this is how we are considering as afterwards. If you are everybody getting same answers and our procedure is also right, then I think we should. If procedure also right, then we have to proceed that these are the correct answers. Then percentage utilization. Then addition we have to go for, it will be heat supplied is equal to how much?
32175.
32175, 32175 kilojoule per kg. If we do the addition here also, heat utilized column, addition will become in this case q plus q1 plus q2 plus q3, all the losses plus heat utilized convert water into steam, and it is equal to 3. Again it is coming, so though it is little bit difference is coming, we have to write it as a 32175, or sometimes it may come exactly also. Correct, na? Okay.
Yes, sir.
Then percentage utilization column we have to go for. Okay. So second column utilization divided by heat supplied. That ratio we are calling as a percentage utilization of heat. And our first percentage of heat utilization is equal to generally boiler
Efficiency.
efficiency. And that way it is efficiency is coming as, can we proceed to next here?
61.25.
61.25%. Then second, okay, so it is 61.25. So what is that? 19, okay, so 19,
708.
19708 point, sorry, divided by 32175. So that is coming as 65 point something. Okay, that will be our
61.25.
61.25. That will be the boiler efficiency. Then here it will be second utilization is the how much heat is going waste, how much amount of heat is going waste in the form of heat dry flue gases or with the dry flue gases. So it is 8.19%. So near about 8.8%, 8.49,
8.49.
8.4949 or 8.5% heat is going in the form of losses, okay, because of the dry flue gases. And then afterwards what? Here it will be moisture. How much moisture is there? Here 0.23%. It is going in the form of moisture. Okay. Then radiation, how much it is going?
30.01%.
Uh, how much? 30%. Huh?
Yes, sir. 30%.
Okay, 30%. And total is coming as about 100. So here what we have to understand from this, which heat loss is more in this case?
Heat loss due to radiation.
Radiation. So if we do some arrangement, that engineer will do some arrangement on the boiler plant, and he will make some successful to bring the heat loss due to radiation. Maybe he can install some project. He can install some proper insulating material for the steam pipelines. Okay, and he will take care that heat will not radiate to the atmosphere. That way that care is going to be taken. Then whatever the heat is going to be saved in that loss, that will be directly utilized to convert water into steam, and that will increase the boiler efficiency. So these heat balance sheets are there. So this gives the idea, corrective measures to for the engineer to increase the performance of that boiler. Okay, the performance of boiler can be increased by studying the heat balance sheet. Now here the heat loss due to radiation is more in this case, so he can bring that loss to 10%. 20% will be adding, 20% will be addition to the efficiency of boiler, or also he can reduce the loss, that is moisture loss, or that first heat carried away by dry flue gases. So that will be directly increase the efficiency of boiler. So generally the heat balance sheets are there. It is going to be the performance sheets, and they can give the corrective measures. It is a result sheet of a boiler. It gives the corrective measures for the engineer to increase the performance of boiler. Or it can by studying this we can get it that in this form heat is maximum heat is going in the form of loss, or how much amount of heat is utilized from that boiler to convert water into steam. So this is the about the heat balance sheet. All of you understood this numerical? Everybody got same answers? So shall we proceed to next unit now? If we say yes, if you give permission, then we'll proceed to our next unit. Shall we? Okay. Yes. Okay. So I think not required to solve. Okay. So efficiency is coming as 61.25%. Then heat uh, carried away by dry flue gases, that loss is coming as 8 point something. Then heat lost due to moisture in the fuel, it is coming as some very less 125 or 0.23%. And then heat loss due to radiation, it's coming as 9,000 something. Okay, 30%. So this way we have drawn the heat balance sheet for this, and these numericals are asking for the examination for not less than 5 to 6 marks. Okay, so okay, I will show you the numerical now. I am trying to complete the assignments, so I am not here. This assignment number 1 already were completed. Okay, so next is this chapter number 1, chapter number 2 I completed. Then chapter number 3, you see the assignment booklet. Then first question, classification of boiler. Okay, and explain boiler, equivalent evaporation, boiler efficiency, incomplete combustion. Okay, so these are the questions they are asking. Then the following data were obtained in boiler trial. 7 mark numerical. Okay. Then 2009, 2018. Already we have covered this. Okay. Then explain construction details of any one high pressure boiler. Okay. These boilers are removed from this. Okay. High pressure boilers. So the following data were obtained during boiler trial. This we have completed. Explain how high pressure boilers are differ from low pressure boiler. So for 4 to 5 methods are difference points we have to give. Then boiler produces wet steam. So that numerical we have covered. In following data were trial. So these trials are asking many times or some that simple numericals that we have taken before starting the heat losses. How to calculate equivalent evaporation, factor of evaporation, okay, then boiler efficiency. For that we should know the things. Now we are going to the unit number 4, that is vapor power cycle. Okay, so shall we go for vapor power cycle? Okay, with these notes we'll take we'll go to the air vapor power cycle. Okay, our syllabus, if you go for the syllabus of vapor power cycle, so our new syllabus, I think lecture first lecture we have gone for, went for. So okay, so let us now focus on this unit. Okay, is screen visible to all?
Yes, sir.
Okay, then syllabus write down now. Unit number 4. Unit number 4. Okay, vapor power cycles. Vapor power cycles. Just a minute, I will see the syllabus exactly. It's a little less syllabus, therefore we should not go for. Okay, so this presentation, I think. So syllabus now you write down this syllabus, okay? Because this syllabus is now reduced somewhat, okay? Vapor power cycles you write down. Is it visible to all?
Yes, sir.
Okay. Write down unit number 4, vapor power cycle. So very short unit you have made. Some articles of last year syllabus, last to previous syllabus we have removed. Vapor power cycle, number of lectures are 4. So this can be used, marking will be, what is weightage for the chapter will be, anybody? Say 1 to 8 marks, correct na? Okay, so unit 1, number 1, classification of cycles, thermodynamic cycles, that we have to go in detail. Then vapor power cycles. Which are the vapor power cycles? Then Carnot vapor power cycle. Carnot vapor power cycle. Then simple Rankine cycle. Then simple Rankine cycle. Then actual Rankine cycle. Actual Rankine cycle. And effect of operating conditions. Effect of operating conditions on Rankine cycle efficiency. Effect of operating conditions on Rankine cycle efficiency. So this is our syllabus for this unit. Have you written? All of you have written. Please reply, because paper for new chapter, very simple chapter, and it we can, if steam table, how to extract data from steam table if we know, then very easy to solve the numericals also on vapor power cycle. Okay, so have you written? So I got only one reply, Shubham Gandole, yes, Kunal, okay. So this is our syllabus, current new syllabus for this. Okay. So everybody have written this is syllabus, because some articles now from notebook are removed. So here last to last syllabus was there. The classification of cycles, vapor power cycles as it is. Okay. Carnot vapor power cycle, simple Rankine cycle, effect of operating conditions on Rankine cycle efficiency. And here additional articles were there for their syllabus. That is ideal heat cycle, open feed water heater. So these are now removed. Okay. So recommended book Thermal Engineering by R.K. Rajput, or course in Thermal Engineering by Dom Kundwar, or an introduction to thermodynamics by Y.V.C. Rao. Then vapor power cycle we have to go for. Okay, so I will not go in detail now in that case. Now, whatever the we have studied, that boiler up till now, the device which generates steam. But whatever the steam is generated by the boiler is utilized mainly in steam power plants. Okay, to generate the power, or some of the industries that we know, sugar industry, etc., for processing purpose, because whatever the steam we are generating from the boiler, it is having two basic uses. One is for processing purpose, and another is what? Power generation purpose. Processing purpose is sugar industries are there, where we to heat the sugar cane juice, okay, with the help of steam, because steam is having high amount of heat or high amount of enthalpy. Therefore, it it is a very fast mechanism to heat any substance. Therefore, lot of a lot amount of sugar cane juice is there in the sugar industry, and it can be heated easily with the help of steam. And for that purpose, we are using the steam. Another purpose is their power generation. Water boilers are there at high pressure boiler. They are generating the steam, and that steam is utilized to generate the power. So steam from the boiler is supplied to the turbines, and the blades of the turbines are get rotated, and these blades of the turbines are connected to the shaft. Okay, as blades are rotated, shaft is also goes on rotating, and if anything is rotating, the displacement happens, and displacement happens means what? Force into displacement is equal to work, and rate of generating of work is nothing but power. So we can generate the power. Anything it is displacing, then generally we say that work is generating. Okay, or to displace anything, we have to produce the work, we have to supply the work, or due to some energy, if any matter, anything, any element is displacing, either it may be reciprocating displacement, to and fro displacement, or it can be rotary displacement. So there we can say mechanical work is obtained. And if that rotations of that shaft, if we carry in the presence of magnetic field, electromotive force is generated. So that is the basic behind the vapor power cycles. Okay. Now here these power cycles we have to study in this unit. But before that, some thermodynamic cycles are there. Okay. Now according to the second law of thermodynamics, we are having two statements. I will revise one or statements. Okay. One is statement is, who can tell me? Second law of thermodynamics. We are having two statements. So one statement is related to, or what is one statement? Anybody? We have taken this 1 or 2 months back. First law of thermodynamics and second law of thermodynamics. Who will tell without fear? Two statements, one statement at least name. We have to give exam. Only one more. Ah, anybody? Okay, Kunal.
The total entropy of an isolated system can never decrease.
No, no, two statements of thermodynamics law. Statements of thermodynamics. Second law of thermodynamics. Statements. Kelvin Planck statement is there. Correct, na?
Yes, sir.
So Kelvin Planck statement, and another is Clausius statement. So Kelvin Planck statement is there. It is related to only engine, and Clausius statement is there. It is related to only heat pump and refrigerators. So by considering these two laws of second law of thermodynamics, one is Kelvin Planck and another is what? Here Clausius. The whatever our thermodynamic cycles are there, they are classified. Now we are going to the first article, that is classification of cycle. The thermodynamic cycles are basically classified into two categories. One is power cycle and another is what? Refrigeration cycles. Okay. The cycles which are responsible to generate the power, okay, by using engines, etc., turbines. So that cycles are called as power cycles. The cycles which are their outcome or their application is what? To give the heat or to refrigerate the space or place. That cycles are called as refrigeration cycles. So our basic thermodynamic cycles are classified into two categories. One is power cycle and another is what? Refrigeration cycle. Then first, this will go to the refrigerant cycle. So in last year in BME, you learned these cycles. So refrigerant cycles are again divided into two categories, depending on the working medium. So refrigerant cycles are divided into vapor refrigeration cycle, vapor cycles, and air cycles. Okay. So air cycles generally. So now here You are having one separate subject in your curriculum, be mechanical, I think final year mechanical, that refrigeration and air conditioning, where all these cycles you are going to learn. All these thermodynamic cycles we are going to learn in our mechanical curriculum. Now we are going to learn this vapor power cycle. One another elective subject may be there in our curriculum where other gas cycles we are going to learn. Okay, so these refrigeration cycles are there. These are divided into two categories. One is vapor cycle and another is air cycles. So these vapor cycles are there. Again, they have divided into two categories. One is vapor compression refrigeration cycle, okay, or vapor VCC, we can call it in bracket short, vapor compression cycle, where the vapors coming from the evaporator or the space are get compressed in the with the help of compressor. So whatever our refrigerator is working, okay, water coolers are working, air conditionings are working. Generally, they are working on the vapor compression cycles, or in short, it is called as VCC. And another is there where compressor is removed, okay, and we are using the absorbing devices, and that refrigeration cycle is called as vapor absorption refrigeration cycles. Vapor absorption refrigeration cycles. So depending on the mechanism, either the refrigerator vapors are compressed or absorbed. Depending on that, first is vapor compression, another is what, vapor absorption. And another cycles are there, refrigeration cycle, where generally they are used for air refrigeration cycle, to process the air. Generally in the aeroplane, we are going to use these two cycles. Okay, so these cycles are there. Joule cycle, this is the name of scientist Joule. And another is there, Breton, Brayton, Breton cycle. So these cycles we are going to learn in detail in our your in subject refrigeration and air conditioning. So similarly, power cycles are also there. They are also basically divided into two categories. One is vapor power cycles, and another is what? Gas cycles. Okay. So gas cycles are there. These are the IC engine cycles. Okay. And another's are there. IC engine means internal combustion engine, where the combustion of the fuel takes place inside the cylinder. Okay, inside the cylinder. So that type of engines we call it as a IC engines. And another cycles are there where the combustion takes place outside the cylinder. Okay, so these are generally considered as what? Air external combustion engine cycles, or generally the gas turbine cycles are there where the combustion takes place outside the cylinder. So these are generally considered as external combustion engine cycles or gas turbine cycles. So these are the gas cycles, IC engine cycle and external gas turbine cycles. And now here we are going to start our chapter. So these power cycles are again divided into two categories. One is vapor power cycle, where the vapors are used, vapors of substance are used to generate the power. So these are called as vapor power cycle. And here the gases, after the combustion, whatever the gas is generating, so that gas is going to be used as a working fluid for generating the power. And here it is a vapor power cycle, like vapors of substance. For example, vapors of water is nothing but steam. Okay, we're using to generate the power. That cycles are called as steam power plant or steam power cycles. Okay, so vapor power cycles, now they are divided into two categories. Firstly, depending on the principle, so first is Carnot, Carnot, Carnot. So first cycle proposed by one scientist, it is called as Carnot. It is called as Carnot vapor power cycle. Then, but whatever the cycle proposed by Carnot is not ideal, is not practical, is ideal only. The processes of the Carnot cycle was not practically possible or feasible, and therefore another scientist made some modification in the Carnot cycle, and that cycle is called as Rankine cycle. And that scientist name is what? Rankine, Rankine, Rankine. And hence, as his name was given to that cycle, and it is called as Rankine vapor power cycle. And therefore afterwards some modifications happened to this Rankine cycle in the form of ideal Reed cycle, ideal regenerative cycle. So intention is to increase the performance or the efficiency of power plant. We are going to add some additional mechanism for that cycle. One is it is ideal read cycle or ideal regenerative cycle. Okay, so these are the classification of thermodynamic cycle. I will revise now one fast in 1 minute. Thermodynamic cycles are classified into two categories. One is power cycle, another is refrigerant cycle. Okay, power cycles are divided into another again two categories. One is vapor power cycle and another is gas power cycle or gas cycles. Then gas cycles are classified into two categories, IC engine cycle and gas turbine cycle. Then IC engine cycles are again classified into two categories. One is SI engine cycle, okay, and another is CI engine cycle. SI means spark ignition engine and CI means compressed ignition engine. So IC engine again it is can be, you can show here to this two arrow. So IC engine is again divided into SI engine and CI engine. And gas turbine cycles are the cycles where generally a combustion happened outside the cylinder. So these are the gas turbine cycle or external combustion engine cycle. Then vapor power cycle, Carnot cycle, Rankine cycle, ideal Reed cycle, ideal regenerative cycle are the types of vapor power cycle. And here in this case, another side, refrigeration cycle. That cycles are again divided into two categories. One is vapor cycle and another is air cycle. Air cycles are used for air conditioning of generally aeroplanes, and these examples are Joule cycle or Breton cycle. And vapor cycles are there. One how the mechanism happens in that refrigeration. Sometimes we have to compress the refrigerator vapors. These are called as vapor compression refrigeration cycle. Sometimes we have to absorb the refrigerate vapors from the space which we want to cool. We have to absorb with the help of some absorber. So these are called as vapor absorption cycle. So these are the classification of thermodynamic cycle. Base is second laws of thermodynamics, two laws. One is Kelvin Planck related to engine. So power cycles are related to engines or Kelvin Planck's laws, and the reference cycles are there. These are working for this Clausius statement. You would understand in brief the classification of thermodynamic cycles. If yes, you can draw this tree diagram for simplicity. Because one or two times they have asked that explain the classification of thermodynamic cycles in detail. If the tree diagram is there, your English is good. You can elaborate in 5 to 10 sentences. If yes, write reply and draw the diagram. Are you understanding? Any doubt? You can okay. Okay, Suhas, yes, he's telling and draw diagram, then draw right up in your Shubham, no problem. Okay, good. Kunal, Rahul Gaikwad. Okay, so this draw this vapor power cycles. Draw it a tree diagram. Girl side, anybody, nobody is understanding. Kapse, Rutuja, Nikita Pawar, Dikshad Mile, and draw a diagram. So 1 or 2 minutes I will give show the screen to you. Nikita Pawar, yes sir. Okay, good. Nikita, done. Okay, very nice. Dikshad Mile, yes, good. This way we should remain active in our class. Finally, I am going to send this notebook for your understanding purpose. If time permits and if our offline lectures will start, then definitely again some difficult parts which you faced the problem that again we can take for more time. Maybe unit number 1, I think more concepts are there. Okay. Shall we proceed? If everybody has done, then we should proceed to next article. Now here we are only concentrating now in this case the vapor cycle, vapor power cycle. This part, this remaining part will take care uh, in our curriculum. Reference cycle in next subject reference and okay, no sir. Prathamesh is waiting. Okay, Prathamesh. Okay. Till I will explain Prathamesh. Prathamesh Patil means not completed or not understood.
Not not completed, sir.
Okay, good, good. So I will explain till that time you complete it. Huh? So vapor power cycle part only we are going to consider in our this unit. Okay. Other parts is there. Refrigeration cycles will be taken care by one subject. Okay. That is refrigeration and air conditioning. After your work, you will complete. Prathamesh, right? Yes. So that I will start. I will proceed to next. So power cycles, vapor power cycle and gas cycles. Gas cycles, another subject is there. Gas turbine cycle. Okay. There we will consider these gas cycles. And now here we are going to cover this Carnot cycle, Rankine cycle, ideal read cycle and ideal regenerative. But again in our case now in this syllabus, as we have given weightage to first chapter more weightage, therefore this ideal reheat and ideal regenerative cycles are removed from our syllabus. But at least we should know that there are ideal read cycle, ideal regenerative cycle, which are implemented in the industries, okay, to increase the performance of a power plant. Power plant means a one of the industry where we can generate the power with the help of working fluids like vapor or maybe gas. These are called as power plant. One subject is also there for the power plant engineering, where you how we are generating the powers that we are going to learn in that subject, power plant engineering. Prathamesh, I think sufficient time.
Yes, sir.
Shall we proceed?
Yes, sir.
Completed, no? Completed? Okay. Then now we'll move over to our the vapor power cycle. Okay. So the vapor power cycle, the power cycles in which working substance used as a vapors of substance or is called as vapors. Is called as vapor power cycle. Okay. I don't know. Vapor power cycles. Heading vapor power cycle. Vapor power cycle. The power cycle in which the power cycle in which working substance the power cycle in which working substance used as used as vapors of substance vapors of substance for in bracket for example steam are called as are called as vapor power cycles are called as vapor power cycles are called as vapor power cycles. Okay. I don't vapor power cycles are are vapor power cycles are mainly first Carnot vapor power cycle Carnot vapor power cycle and second write down Rankine Rankine. So that girl that student has made mistake here. Rankine vapor power cycle. Carnot vapor power cycle and second is what? Rankine vapor power cycle. Now Carnot vapor power cycle means what? It is proposed by a Carnot or it is prepared by a Carnot. That is called as Carnot vapor power cycle. And Rankine, the name of scientist Rankine, Rankine, Rankine has proposed this cycle, hence the name is given as Rankine. Other than these two, there is no difference. Carnot means it is suggested, proposed by Carnot, hence Carnot vapor power cycle. And Rankine is what? Rankine vapor power cycle means it is a cycle in which it is cycle is proposed by Rankine. Okay, next line write down. Carnot vapor power cycle. Make heading Carnot vapor power cycle. Carnot vapor power cycle. Now Carnot the cycle is proposed by Sadi Carnot. The cycle is proposed by Sadi Carnot. SADI Sadi Carnot. Now, in our first law, in basic laws of thermodynamics, one cycle we have studied. That is also called as Carnot cycle. And that cycle was also an ideal cycle, not practically feasible cycle. Here also, whatever the Carnot vapor power cycle is there, so that is a Carnot gas cycle. Okay, but here working substance is vapor, and whatever the Carnot has suggested this vapor power cycle, it is also ideal cycle or hypothetical cycle. Okay, because it has considered is consisting of two processes are reversible processes and two processes are isothermal processes. So two processes in this Carnot cycle has suggested how many processes? 4. Out of that, 2 are reversible and 2 are isothermal. Write down. It is an hypothetical cycle. It is proposed by Carnot, Sadi Carnot, and is an hypothetical cycle which consists two reversible processes and two isothermal processes. Two reversible processes and two isothermal processes. Then write down. Compression and expansion are isentropic. Compression and expansion are isentropic. And okay, full stop. Heat rejection and heat addition heat addition and heat rejection are isothermal processes. Heat rejection and heat addition are isentropic processes.
Sir, repeat again.
Heat addition, heat rejection and heat addition from this or from initial heat addition and heat rejection
Two
are
reversible and two isothermal processes.
two reversible and two reversible and two isothermal processes. Okay, then write down. Expansion and compression are isentropic processes. Full stop. Heat rejection and addition are isothermal processes. So this Carnot vapor power cycle consists of 4 processes. 2 are isentropic processes or reversible processes that way, and 2 are isothermal processes. But we know that in the universe or in the world, there is no process reversible process. All the processes are irreversible processes. Some extent, few processes we call it as reversible. But here, reversible processes are not possible in the universe. And isothermal heat addition I means when we add the heat, generally temperature increases, and when we reject the heat, temperature generally falls or decreases. Therefore, during the heat addition and heat rejection, temperature very difficult to maintain the temperature constant. So because of these two things, because of means reversible processes are not possible. Ideal processes. Isothermal heat addition is also one of the ideal concept. So because of this, whatever cycle is proposed by Carnot is remain as a ideal cycle, hypothetical, or it remained on paper only. It is a dream cycle only. Okay. What components are Carnot has suggested? Write down. Now write down. Schematic of Carnot vapor power cycle. Schematic of Carnot vapor power cycle. Schematic of Carnot vapor power cycle. So, write down. First is there. Draw the schematic. Okay. So it is a boiler. So make water is here in the boiler, and it is converted into steam. So this steam you draw. I will explain, and you draw while I am explaining. Boiler is there, is generating the high pressure, high temperature steam. So this steam is supplied to the turbine. So another component of Carnot vapor power cycle is steam turbine. Okay. So this high pressure, high temperature steam is supplied on to the turbine. Okay, where it uh, strikes the blades of turbine, and whatever heat is there, that heat is going to be, whatever heat of steam is there, it goes on decreasing, and expansion of the steam happens because in the turbine the pressure of that steam decreases. Okay, and whatever the heat is decreased, that amount, whatever amount of heat decreased, same amount of work we can get from this turbine. Then after expansion, the steam will become low, become low pressure. As it is condensed, some of the steam is get condensed. Temperature of that steam also get less, and that low pressure, low temperature steam is supplied to the condenser. Okay, and this condenser again at isothermal condition converts that start to convert that vapor of the steam back to the liquid. Okay, and then afterwards this mixture is there, again it is converted, supplied to the boiler. Okay, and then again boiler generates steam, again this steam, high pressure temperature steam is impacted on the blades of turbine. Okay, then expansion happens in the turbine, whatever the heat is decreased, equally it is converted into W work, and remaining steam after the expansion, the steam will become low pressure and its temperature also get decreased, low temperature, and this steam is supplied to the condenser, and this condensate, after condenser whatever steam we are getting, it is a condensate, this condensate we are supplying to the boiler, but the temperature of the condenser is very low because expansion happens in the turbine. Therefore, to supply this condensate, return to boiler, we have to increase its pressure. And for that, one device we are using, that device is called as compressor. So, this, have you completed the schematic? Schematic completed? Yes. Okay. So, now give the numbering for the processes. 4 to 1 boiler process is there. It is 4 to 1 boiler. Okay, boiler means it does, here it is water is added. Okay, at the same time that water will take the heat from the combustion of the fuel, and it is get converted into steam, high pressure, high temperature steam. Then this 1 to 2, here it is not 2, here it, sorry, it is will be 2 will be here. Okay, or shall I draw the schematic? Okay, this is going to be the boiler. From this boiler, high pressure. So this will be high pressure. High temperature steam. High pressure, high temperature. Is impacted on the blades of turbine. So how much? This is a steam turbine. ST will call it steam turbine. Okay, high temperature steam. So after doing the expansion, the pressure of that steam is decreased. Temperature of that steam is also decreased. So this low pressure, after expansion, the steam will become having temperature become low pressure as a steam, and low temperature, low pressure and low. Is supplied to the is called as condenser. Okay. After that, what are the condensate we are getting? So this is condensate. This device we call it as a compressor. It's compressor. Okay. So whatever the boiler is there, boiler process is there four. This will be one. Okay. Generation of steam in the boiler, heat addition in the boiler is a 4 to 1 process. This is a steam 1 to 2 will be turbine process. So inlet will be 1, and this is 1 to 2 is the turbine process, and 2 to 3 is a process in the condenser, heat rejection in the condenser, and 3 to 4 is again compression in the compressor. So these are the four important devices that we are using in the for this particular Carnot vapor power cycle. Then, which are the four processes now? We'll write one by one. What happens now? Steam is generated in the boiler at constant pressure. Okay. So this steam is after generating the steam, its pressure is high, temperature is also high. This high pressure, high temperature steam is impacted on the blades of turbine. Okay, in the turbine, what will happen? The turbine, what will happen? The steam is expanded isentropically in the turbine, and due to that, what will happen? The work is obtained in this particular turbine. Whatever amount of heat is decreased by the first law of thermodynamics, heat can be converted into work, or work can be converted into heat. Whatever decreased amount of heat is there, it is converted into work. Then after decreasing heat, its enthalpy decreases, expansion pressure decreases. As enthalpy decreases, pressure decreases, temperature of the steam is also goes on decreasing. And this steam having low pressure, low temperature steam is passed through a device. It is called as condenser. In the condenser, what will happen? Again, conversion that whatever the vapors are there, low pressure, low temperature vapor or steam, is back reversely converted into liquid or water. Okay, where the heat is rejected from the steam reject the heat, or we can take the heat from that steam. Okay, that heat can be released to atmosphere. Okay, and here steam is going to be, or that steam is get cooled, and that steam is get cooled means it is converted into water or a mixture of water and vapor, and this is called as what? Condensate. So this mixture is generally called as what? Condensate. Okay, and this condensate is having low pressure because it is expanded in the turbine. To increase the pressure and to supply back to the boiler, we have to increase the pressure, and for that we use the device compressor. So these are the four devices used in the Carnot vapor power cycle. Now we'll go for the processes. Which are different processes in the Carnot cycle? The first process is there, generally we call it as a 4 to 1, and it is heat, or we can say it as a isothermal, because temperature where Carnot assume that during this process heat should be, temperature should be remain constant. So it is what? Isothermal heat addition, because we are adding the heat and water is get converted into steam. So in the water we are adding the heat. So heat, isothermal heat addition, where it happens, we'll tell. Heat addition happens in, anybody?
Boiler.
Boiler. So isothermal heat addition in boiler is the first process according to the Carnot. Then 1 to 2. What happens in the 1 to 2 process? Anybody of you? It is which process? Which happens in which device? It is isentropic or reversible. Isentropic. Here expansion, because where steam is high pressure steam, high temperature steam is impacted on the blades, it get goes for expansion. Now what, how the turbines work? For that we are having separate in steam turbine, don't worry. Isentropic expansion of steam in steam, I'm writing shorter, in steam turbine. Okay, and 2 to 3, now we will tell 2 to 3. To make the cycle complete, you have to go for again same process, isothermal. Who will tell? Write down this also diagram, after drawing diagram, schematic. So these four processes: isothermal, isothermal,
Heat rejection.
correct. Isothermal heat rejection. isothermal heat rejection. Where heat is rejected, the device is called as isothermal heat
Condenser.
rejection in condenser. And then 3 to 4 is what is 3 to 4 process? Anybody of you? 3 to 4 process? Exactly opposite to this isentropic expansion. Isentropic
Compression.
isentropic compression in which device?
Compressor.
Compressor. These are the four processes. Isentropic compression in compressor. Okay, so these are the four processes. You would understood this Carnot cycle? What schematic? What are different four processes up till now? Reply fast. Yes, yes. Rahul Gaikwad, no problem. Okay. Now draw this. Have you drawn schematics? Schematic. Have you written all the four processes? Two processes are isothermal and two are isentropic. Okay. Then, accordingly, you have written all four processes also. Considering this, okay. Now these four processes I have written. We have started from 4 to 1. 4 to 1 is heat addition in boiler. Okay, 1 to 2 is isentropic expansion of steam in steam turbine. 2 to 3 is isothermal heat rejection in condenser. Then 3 to 4 isentropic compression of condensate in compressor. And then after I have taken this heat addition first, isothermal heat addition in boiler. Okay. Now we have to draw the PV diagram of the Carnot cycle. Okay. Now this is our saturation curve. Okay. Okay. So draw diagram with me now. PV diagram of the Carnot cycle. First understand and draw. It is not that much big. PV diagram. Okay. Now here PV means pressure versus volume diagram. Okay. Now here we have to draw the saturation curve because phase change is there. This cycle is there. In boiler, what happens? Water is get converted into steam. Means liquid is get converted into vapor. And in condenser, what happens? Vapor is backly converted into water. Therefore, this phase diagram, our saturation curve, is very much important. This kind of saturation curve is there. Okay. Here we know that it is a critical point. Okay. And this critical point, here we know that it is which line is there? Anybody of you? Saturation curve we have written, completely studied. This is which line? Anybody? It may be PV diagram, it may be TA diagram. This is a anybody of this everything on this line is a
Saturation liquid
correct.
line.
It is a saturation liquid line. Okay. And here it is critical point. And after that it is a which line is there? Anybody? Saturated
Saturation wafer
vapor
line.
line. It is here all things are there in this is a vapors, and here it is liquid line, it is a vapor line. Now what happens here, liquid is having less specific volume, and when it get heated it is converted into gas or vapors, and their vapors are having more specific volume. Okay, therefore liquid is having this is to left side means having less specific volume, and when we heat them its specific volume goes on increasing. Okay, now here in this diagram how many pressures are there? Maximum pressure where it is there, anybody? So there are two
At
pressures.
critical
Who is telling? How many pressures are there? Before turbine, because expansion happens in turbine. Before turbine, the process pressure is very high. After turbine, the pressure is, anybody? Pressure is very low. Okay. So there are, as it is a PV diagram is there. So pressure lines are there. We can like this. We can draw like this. So it is a, this one pressure is there. Another is there. It is another pressure line is there. So here the pressure before turbine, what is device is there? Anybody? Before turbine, what is device is there?
boiler.
Boiler. So here it is, we can call it as a boiler. So this is a boiler pressure line because it is highest. And here where the pressure is less after turbine, what is device is there? Anybody
Condenser.
of you? Condenser. So pressure PC is a condenser pressure. It is the lowest pressure in the this particular cycle. And highest pressure is in the boiler. Okay. And here it is condenser. Pressure is less. Now what happens? Pressure here the temperature is remains constant when we add the heat in boiler, and when we add we take the heat from the condenser, therefore temperature is remaining constant. And we know that during phase change only temperature is remaining constant. If we go out from this page, here outside curve, temperature is not remaining constant. So nature is like this, temperature nature. So it is going to be in the curve, only in the curve it is remaining constant. Outside the curve temperature may increase. Means to have the boiler heat addition in boiler isothermal, what we have to do is we have to remain inside the curve only. We have to remain inside the curve only. Okay, and if we go outside the curve, what will happen? Anybody? What will happen? Temperature will not remain
Temperature
constant. Temperature will
constant.
is increasing, or here if we are going in this direction it will maybe decreasing. Means temperature is remains constant only when here phase change occurs. Otherwise, other else the temperature remaining only here will not be remain constant. Therefore, there are two processes. One is boiler. Okay, let us consider now 4 to 1. We'll consider this as a process. Point number 1 will give 4. Let us liquid we are supplying to the boiler at this point. Okay, at 4 point, and it is get converted at constant pressure. The water is get converted into air vapor. We are not going to consider the superheated steam from the Carnot cycle. Why? सांगावर कोण सांगते? सुपरहिटेड स्टीम आपल्याला कार्नोट सायकल मध्ये तयार करता येत नाही का? बघू आता. How many of you are listening or okay using concept, applying concept? इथं आपल्याला सुपरहिटिंग स्टीम तयार करता येत नाही का? कोणीतरी एकानं
टेम्परेचर कॉन्स्टंट.
isothermal
तिथे आयसोथर्मल प्रोसेस आणि तिथे टेम्परेचर काय राहिलं पाहिजे? कॉन्स्टंट. म्हणून सुपरहिटिंग ह्याच्यामध्ये पॉसिबल नाही. आणि हे एक कार्नोट सायकलचं काय आहे? लिमिटेशन. दिस इज वन ऍक्टिंग ॲज वन ऑफ द लिमिटेशन ऑफ कार्नोट सायकल. ओके, फक्त आपल्याला मॅक्झिमली वी कॅन गो फॉर वेट स्टीम ऑर ड्राय अँड सॅच्युरेटेड स्टीम. सुपरहिटिंग स्टीम आपल्याला इथं मिळणार नाही, कारण हीट ऍडिशनचं टेम्परेचर आपलं काय आहे? कॉन्स्टंट आहे. आणि जर आपल्याला ते सुपरहिटिंग स्टीम म्हणलं तर टेम्परेचर कॉन्स्टंट राहणार नाही. म्हणून सुपरहिटिंग इज नॉट पॉसिबल इन कार्नॉट व्हेपर पॉवर सायकल. ओके. नंतर आता इथे 4-1 आपल्याला स्टीम मिळाली. कुठली मिळाली समजा, लेट अस कन्सिडर दॅट स्टीम इज जनरेटेड इज अ ड्राय अँड सॅच्युरेटेड स्टीम. बिकॉज काय ड्राय अँड सॅच्युरेटेड, कारण इथं टेम्परेचर सॅच्युरेशन आहे आणि इथं त्याचं काय सगळे मॉइश्चर इथं 100% काय एक्स इज इक्वल टू काय असतो इथं ट्रान्सफॅक्शन ऑफ वेपर लाईन एक्स इज इक्वल टू काय असतं नेहमी 1 आणि लिक्विड लाईन एक्स इज इक्वल टू काय असतं नेहमी
0.
0. म्हणजे सगळे 100% स्टीम ड्राय इथं कन्वर्ट झालेले आहे वॉटर वेपरमध्ये, त्यामुळे ह्याला ड्राय म्हणतो. आणि ड्राय अँड सॅच्युरेटेड आणि टेम्परेचर त्याचं किती आहे सॅच्युरेशन म्हणून त्याला आपण ड्राय अँड सॅच्युरेटेड स्टीम म्हणतो. नंतर 1 to 2. व्हॉट इज 1 to 2 प्रोसेस? What is the 1 to 2 process? Isentropic expansion in turbine. ओके. आणि इथं एक्सपान्शन मध्ये काय होतं नेहमी व्हॉल्यूम गोज ऑन इन्क्रीजिंग अँड प्रेशर इज गोज ऑन डिक्रीजिंग. कुठून कुठं प्रेशर डिक्रीज होतं त्याचं? प्रेशर डिक्रीजेस फ्रॉम बॉयलर प्रेशर टू condenser pressure, and that happens in which device? In steam turbine. This happens in what? Which device? Steam turbine. ओके. आता आपल्याला काय करायचंय, इथं एक्सपान्शन झालं नंतर आपण जे राहिलेली प्रेशर लो प्रेशर स्टीम आहे आपली एक्सपांड टर्बाइन मध्ये लो प्रेशर स्टीम, बिकॉज हिअर प्रेशर डिक्रीज्ड आणि इथे काय झाले टेम्परेचर पण त्याचं काय होणार आहे डिक्रीज होणार आहे. लो प्रेशर लो टेम्परेचर स्टीम इज पास्ड टू द कंडेन्सर. आता कंडेन्सर मध्ये काय करतोय आपण वेअर कूलिंग, याच्या अपोजिट इथं आपण हीट करतोय बॉयलर मध्ये, इथं काय करतोय कूलिंग, मे बी एअर कूलिंग असेल वॉटर कूलिंग असेल, त्यानुसार आपण काय करतोय ते स्टीम आपण काय करतोय लो प्रेशर लो टेम्परेचर स्टीम आपण हिअर वी आर गोइंग टू condense. Okay, and that steam we are going to condense here. Okay, and this steam we call it as a here afterward means it rejection is happens, but afterwards in compressor we have to compress the liquid, and to compress it again what we have to go for, pressure is goes on increasing and volume is goes on decreasing, and this happens in the compressor. आपल्याला हे कॉम्प्रेसर तुम्ही वर्ड इकडे लिहा. ओके, तर आपल्याला इथून आता हा प्रोसेस आहे 1 to 2, 2 to 3 happens at condenser pressure 2 to 3 and 3 to 4 ला काय आहे अगेन काय सेंट्रोपिक कॉम्प्रेशन. आता इथं जे आपलं आहे इथं काय म्हणतोय आपण ह्याला मिक्सचर. ओके, इथं जर पॉईंट आपल्याला 4 काढायचा असेल तर आपल्याला कॉम्प्रेशन कंडेन्सेशन इथंच थांबवावं लागेल. तर इथं तुम्ही नेलं कंडेन्सेशन तर हे काय पॉईंट जाईल हा बाहेर जाईल, आणि बाहेर जर गेलं तर इथं आपलं हीट आयसोथर्मल हीट ऍडिशन होईल का? बाहेर टेम्परेचर काय राहतं नेहमी टेम्परेचर नॉट रिमेनिंग कॉन्स्टंट, फक्त टेम्परेचर कुठं राहील कॉन्स्टंट ह्या फेज चेंज मध्ये. ही फेज चेंज आहे लिक्विड टू व्हेपर, ह्या फेज चेंज मध्ये टेम्परेचर रिमेन्स कॉन्स्टंट, बाहेर टेम्परेचर रिमेन्स कॉन्स्टंट राहत नाही. टेम्परेचर काय होईल आयदर चेंज वाढेल किंवा कमी होईल डिपेंडिंग ऑन द प्रोसेस. जर तुम्ही हिटिंग करत असेल तर टेम्परेचर वाढणार, कुलिंग करत असेल तर टेम्परेचर कमी होणार, कारण की हीट कशी आहे सेन्सिबल हीट आहे, इथे लॅटेंट हीट आहे. ओके, म्हणून तुमची हीट कंडेन्सेशन हिटच आपल्याला स्टॉप करावं लागतंय कुठलं कार्नोट सायकल मध्ये. नंतर हे आपण लिमिटेशन बघणार आहे. एव्हरीबडी अंडरस्टँड दिस डायग्राम, पीव्ही डायग्राम? एव्हरीबडी अंडरस्टँड? येस असेल तर येस मला वाटलं काय ऑनलाईन. ओके, सो मी तुम्हाला ते डायग्राम नोटबुक मधलीच काढायची आपल्याला, फक्त तुम्हाला इथे अंडरस्टँड होण्यासाठी हे करतोय. आणि हे समजलं तर तुम्हाला पुढच्या गोष्टी समजणार आहेत, म्हणजे कार्नोट सायकलची लिमिटेशन्स वगैरे. ओके, इथे पण पुन्हा अजून असं सॅच्युरेशन कर्व काढू आपण. ओके, आता टेम्परेचर सगळ्यात जास्त कुठं असणार आहे? टीएस डायग्राम आपण चालूया आता. टेम्परेचर सगळ्यात जास्त कुठं असणार आहे? टेम्परेचर वर्सेस एंट्रॉपी. टेम्परेचर सगळ्यात जास्त कुठं असणार आहे? बॉयलरला. इथं पण बॉयलरचं टेम्परेचर आहे. आता हीच प्रोसेस आहे अशीच, इथे लिक्विड लाईन आहे, प्रत्येक वेळेस मी आता लिहून बसत नाही, लिक्विड लाईन, क्रिटिकल पॉईंट आणि वेपर लाईन. तर तुमचा 4ला काय झालं, आपण वॉटर इज गोइंग टू बी सप्लाय टू द बॉयलर, जे सॅच्युरेटेड आहे वॉटर, आणि दॅट इज कन्व्हर्टेड इन टू व्हॉट, स्टीम. ते कशामध्ये कन्वर्ट झालं, डिव्हाइस इज बॉयलर. ओके. आणि इथं प्रेशर काय असल्यामुळे कॉन्स्टंट असल्यामुळे इथं फेज चेंज असल्यामुळे टेम्परेचर सुद्धा रिमेन कॉन्स्टंट, प्रेशर पण रिमेन कॉन्स्टंटच, पण इथं काय होईल, टेम्परेचर सुद्धा काय होईल, कॉन्स्टंट राहील. याच्या बाहेर गेल्यानंतर मात्र टेम्परेचर कॉन्स्टंट राहणार नाही, याच्या बाहेर किंवा याच्या बाहेर टेम्परेचर कॉन्स्टंट राहणार नाही. म्हणून कार्नोट सायकल हा फक्त त्या कर्व मध्येच राहील. कार्नोट सायकलला कर्वच्या बाहेर जातच येत नाही, कारण हीट ॲडिशन आणि हीट रिजेक्शन टेम्परेचर कसं, हीट रिजेक्शन प्रोसेस इज हॅपन्स ॲट कॉन्स्टंट टेम्परेचर, हे ॲज्युम. आता 1 to 2 कसली प्रोसेस आहे आपली, विल टेल. 1 to 2 कसली प्रोसेस आहे, टर्बाईन मध्ये काय होतं, आयसेंट्रॉपिक. म्हणजे काय होईल, मला कसली लाईन काढावी लागेल, व्हर्टिकल, कम्प्लीट व्हर्टिकल. कारण काय प्रोसेस कशी आहे, आयसेंट्रॉपिक म्हणजे एंट्रॉपी रिमेन कॉन्स्टंट. आयसेंट्रॉपिकचा अर्थ काय, एंट्रॉपी इज रिमेनिंग कॉन्स्टंट. कुठली प्रोसेस मध्ये, 1 to 2 मध्ये. ओके. आणि नंतर 2 to 3 मध्ये हीट काय होते आपली, रिजेक्ट होते. कुठल्या डिव्हाइस मध्ये रिजेक्ट होते, कंडेन्सर मध्ये. ओके, कंडेन्सर. इथून पुढं पुन्हा अजून काय होते, आयसेंट्रॉपिक काय आहे, कॉम्प्रेशन इन 2 to 3 आणि कॉम्प्रेशन. हे कुठली तुमची प्रोसेस आहे, आयसेंट म्हणजे बॉयलर मध्ये 4 to 1 टेम्परेचर रिमेन कॉन्स्टंट, 4 to 1. बघा TS डायग्राम आहे, TS 4 to 1 आयसोथर्मल हीट ॲडिशन, फक्त एन्थाल्पी वाढल्यामुळे एंट्रॉपी पण काय होते, वाढते. 1 to 2 आयसेंट्रॉपिक एक्सपान्शन टर्बाईन मध्ये, म्हणून ते काय होईल, व्हर्टिकल लाईन, एंट्रॉपी रिमेनिंग कॉन्स्टंट. आणि 2 to 3 कंडेन्सर मध्ये कुलिंग करते म्हणल्यावर एन्थाल्पी डिक्रीजिंग, एंट्रॉपी पण काय होईल, त्या प्रमाणात डिक्रीज होईल. 2 to 3 आणि 3 to 4 अगेन कॉम्प्रेशन. ओके. ही तुमची कुठली डायग्राम आहे, टीयर डायग्राम. याला आपण म्हणू शकतो, आपण हीट ॲडिशन टेम्परेचर T1 म्हणलं, इज इक्वल टू T1 इज इक्वल टू T4 आणि T2 इज इक्वल टू T3. याला जर हीट रिजेक्शन टेम्परेचर आपण याला म्हणलं T2, इथं म्हणू शकता तुम्ही T2. ओके. इथं म्हणू शकता तुम्ही T1. Okay, we got it. Now we'll go to our okay. Now this is our diagram. Okay, everybody got it. PV diagram, and this is going to be TA diagram. Draw it. Or drawn?
No, sir.
Draw it.
Clear and not visible.
Not visible clearly, but now you got idea, na? This is boiler 4 to 1, 1 to 2. Or shall I keep that my, this is okay, this is okay, because this is not, or can you keep this, or can you go for that notebook? Because here it is boiler, turbine, ST turbine. Here नाव देताना फक्त कॉम्प्रेसर इकडच्या लाईनला द्या, टर्बाईन इकडची द्या, म्हणजे तुम्हाला कन्फ्युजन होणार नाही. मला इथे कसं आहे, माझा माऊसनं मी ऑपरेट करतोय सगळं डायग्राम. तेव्हा मला ते लिहायलाच अवघड जाते. म्हणजे ते माऊस हा माऊसचा उपयोग मी ॲज ए मार्कर करतोय. आय एम गेटिंग लिटल बिट ट्रबल टू राईट द लेटर्स. Okay, so temperature is remaining constant during heat addition as well as heat rejection. The entropy is remaining constant during expansion and compression. So this is our cycle, and cycle will not extend, will not come outside the curve. Ka? This is very important concept, valid reason. म्हणून Carnot cycle possible नाही आहे आपल्या म्हणून, किंवा लिमिटेशन्स आपल्याला बघायचे नंतर. व्हॉट आर लिमिटेशन्स ऑफ Carnot cycle? तर पहिलं लिमिटेशन काय आहे, मगाशी बघितलं आपलं काय, सुपर हिटिंग स्टीम मिळणार आहे का आपलं, सुपर हिटेड स्टीम किंवा सुपर हिटिंग ऑफ स्टीम इज नॉट पॉसिबल. पहिलं मेन लिमिटेशन काय Carnot सायकलचं, सुपर हिटेड स्टीम मिळणार नाही, कारण टेम्परेचरची हीट ॲडिशन, बट हीट ॲडिशनच्या वेळेस टेम्परेचर काय आहे आपलं कॉन्स्टंट राहते, आणि हीट रेडिएशनच्या वेळेस पण टेम्परेचर कॉन्स्टंट राहते. ओके, आय थिंक यू हॅव कंप्लीटेड. Then write down efficiency of Carnot cycle. Efficiency of Carnot cycle. Efficiency of Carnot cycle in bracket eta Carnot. Efficiency of Carnot cycle in bracket eta Carnot. Efficiency of Carnot cycle efficiency of Carnot cycle in bracket eta Carnot. Efficiency of Carnot cycle in bracket eta Carnot is defined as ratio of work obtained to the heat supplied to the cycle. Eta Carnot is defined as ratio of work obtained to the heat supplied. Heat supplied. Now, if you draw the thermodynamic, first law of thermodynamics, here Kelvin Planck statement for this Carnot cycle, then this is our cycle, okay, a turbine we can say, ST turbine. From turbine we are getting the work. So one of the source is there, it is always at the highest temperature, it is called as boiler. So boiler, the heat is supplied to this particular cycle, okay, boiler, turbine, work is obtained. Let us consider the boiler is supplying QS or Q1, QS amount of heat to the turbine. Turbine is generating W amount of work. At the same time, it have to, anybody have to reject some amount of heat, that is QR. Okay, and to the another reservoir which is at low temperature. What is that low temperature reservoir? Anybody? झालं माझं. ओके, कंडेन्सर. म्हणजे फर्स्ट लॉ ऑफ केल्विन प्लॅंक स्टेटमेंट, सेकंड लॉ ऑफ thermodynamics, if you apply to this system, overall system, then it is boiler is supplying QS amount of heat, turbine is there, it is generating, it is a engine because it develops the work, cyclic operating device. Okay, W amount of work is generated and rejected amount of it will be QR to the low temperature reservoir. Let us consider this as temperature is T2, this is a T1. T1 is equal to T4, T2 is equal to T3. Okay, now this work obtained, let us consider this as a W. Okay, and this is the heat supplied is equal to QS. How much amount of heat is supplied from boiler? It is QS. Okay, but from figure, what is W? कोण सांगते? ऍक्टिव्ह पार्टिसिपेंट पाहिजे. व्हॉट इज डब्ल्यू? डब्ल्यू काय आहे?
QS minus QR.
QS मायनस QR म्हणजे एवढी हीट सप्लायड मायनस हीट रिजेक्ट. करेक्ट. सो QS minus QR. Correct. QS minus QR divided by QS. You will understand this? This equation number 1. Write down. Write with me. So eta Carnot mathematically write down. Then mathematically eta Carnot is equal to work obtained divided by heat supplied, or is equal to work obtained W divided by QS, or QS here diagram कुठे तर साइडला काढा. T1 boiler temperature T1. Okay, there the temperature heat supplied is QS, turbine is a device generating W amount of work and rejecting QR amount of it to the condenser. हा सोर्स झाला, हा सिंक झाला. ओके, आता QS, हाऊ टू कॅल्क्युलेट QS? हीट सप्लाय टू QS. आता QS मध्ये काय असतं लक्षात ठेवा. आता ह्या QS मध्ये हिअर हीट सप्लायड इज इक्वल टू, आपल्याला जर तुम्ही डेफिनेशन बघितली असेल एंट्रॉपीची, जर काय असते एंट्रॉपी डेफिनेशन, DS इज इक्वल टू जनरली काय असते DQ बाय T, इंटिग्रेशन किंवा समेशन DQ बाय T. ओके, तर आता आपल्या टोटल एंट्रॉपी चेंज DS जनरली म्हणलं आपण, DS म्हणलं तर, पण हीट ॲडिशनच्या वेळेस आयसोथर्मल प्रोसेसमध्ये टेम्परेचर काय राहतं? कॉन्स्टंट. म्हणून DS ची डेफिनेशन आहे, एंट्रॉपी डेफिनेशन DS इज इक्वल टू इंटिग्रेशन DQ बाय T. तर T हा नेहमी काय राहील? आउट ऑफ इंटिग्रेशन येईल. का? तर टेम्परेचर रिमेन कॉन्स्टंट आयसोथर्मल प्रोसेसला. आणि हे जर आपण टोटल जर घेतलं आपल्याला, तर Q अमाऊंट ऑफ हीट सप्लायड विल बी QS. ओके, ह्याला आपण म्हणू शकतो आपण डेल्टा एस. DS इंटिग्रेशन टोटल घेतलं आपण, डेल्टा इज इक्वल टू 1/T इंटू QS. म्हणजे QS इज इक्वल टू काय होऊ शकतो? आयसोथर्मल प्रोसेसला QS इज इक्वल टू काय होऊ शकतो? T इंटू डेल्टा एस. हा फॉर्म्युला लक्षात ठेवायचा. कशावरून आला हा? आयसोथर्मल प्रोसेससाठी Q इज हीट सप्लायड किंवा हीट इंटरॅक्शन इज इक्वल टू टेम्परेचर ॲट विच दॅट हीट इंटरॅक्शन हॅपन्स इनटू एंट्रॉपी चेंज ड्युरिंग दॅट प्रोसेस. ओके, तर इथं लिहायचं फॉर आयसोथर्मल प्रोसेस, लिहा फॉर आयसोथर्मल हीट ॲडिशन, फॉर आयसोथर्मल हीट ॲडिशन, फॉर आयसोथर्मल हीट ॲडिशन लिहिता आहे ना? ऍक्टिव्ह पार्टिसिपेंट हा लिहिता आहे? ओके, फॉर आयसोथर्मल हीट ॲडिशन QS इज इक्वल टू काय असतो नेहमी? T इंटू ह्याच्यातला डेल्टा एस. का? तर डेफिनेशन आलेलं आहे QS इज इक्वल टू T इंटू डेल्टा एस आयसोथर्मल हीट ॲडिशन मध्ये. ओके, QS इज इक्वल टू T इंटू डेल्टा एस. आता QS ला जावा. टेम्परेचर किती राहते आपलं शिल्लक? इथं कॉन्स्टंट कुठलं टेम्परेचर राहते बॉयलरला? T1 इज इक्वल टू T4. त्याला आपण काय म्हणू शकतो? T1. आणि एंट्रॉपी चेंज ज्यावेळेस ते पाणी तुमचं बॉयलरमध्ये जाणार आहे त्याच्यावेळेस त्याची एंट्रॉपी समजा S4 म्हणलं, आणि जेव्हा ते स्टीम तयार झालं तेव्हा त्याची एंट्रॉपी जर S1 म्हणलं, तर किती एंट्रॉपी चेंज झाला त्या सबस्टन्स मध्ये सांगा बरं? डेल्टा एस किती झाला? डेल्टा एस किती झाला? S1 मायनस इथे S4 आहे, आणि टायर फायनल एंट्रॉपी काय S1 आहे. तर दोघा ऍड किती झाली इथं, चेंज किती झाला, S1 मायनस
S4.
S4. तर पुढची म्हणून इथं QS या सिंपल पद्धतीने आपण काय म्हणू शकतो, therefore QS इज इक्वल टू टेम्परेचर ॲट विच टेम्परेचर कॉन्स्टंट राहिलं T1 किंवा T4 म्हणू शकतो आपण. T1 इन टू ब्रॅकेट काय S1 मायनस S4 लक्षात. ओके. सिमिलरली आता QAR हीट ऍडिशन पण कशी होते इथं ह्याच्यामध्ये, ह्याला वन इक्वेशन म्हणा. हीट रिजेक्शन पण कशी होते इथं, ऍट कशाला होते, टेम्परेचर काय राहतं तिथं पण काय राहतं कॉन्स्टंट, म्हणून QR इज ऑल्सो इक्वल टू T इंटू डेल्टा S. म्हणून का तर डेफिनेशन ऑफ एंट्रॉपी DS इज इक्वल टू इंटिग्रेशन DQ बाय T, आणि टी इंटिग्रेशन बाहेर कधी येऊ शकतो आयसोथर्मल कंडिशनच्या वेळेस. ओके. तर म्हणून QR थोडा काय झाला आपला, दिस QR टेम्परेचर किती आहे T2 आणि इंटू काय झालं, कुठे आहे कुठे गेलो आपण. तर काय ह्याची एंट्रॉपी काय असणार आहे, पॉझिटिव्ह चेंज घ्यायला. इथं ज्या वेळेस आपण जाणार आहे त्यावेळेस एंट्रॉपी काय आहे त्याची S2
S2
मायनस
S3.
S. ओके, एव्हरीबडी गॉट इट. इथली एंट्रॉपी काय असणार कंडिशनची, इथली S3 म्हणजे 0.1 ची एंट्रॉपी S1, 2 ची S2, 3 ची S3 आणि 4 ची S4. त्याप्रमाणे आपण काय करू शकतो, T2 इंटू ब्रॅकेट काय म्हणतो आपण S2 मायनस S3. You understand? Okay. Therefore, eta Carnot is equal to काय T1 into bracket S1 minus S4, okay, minus T2 into bracket S2 minus S3 divided by T1 into bracket S1 minus S4. Okay. But from figure S1 आणि S2 मध्ये काय रिलेशन आहे, S1 आणि S2 मध्ये रिलेशन काय आहे एनीबडी, आणि S3 आणि S4 मध्ये रिलेशन काय आहे, S1
is equal to S2.
S3 इज इक्वल टू,
S4.
बिकॉज कुठली प्रोसेस आहे त्याची, दोन्ही पण कसल्या प्रोसेस आहेत आयसेंट्रॉपिक. म्हणून इथं आपण काय म्हणतोय S1 इज इक्वल टू S2 आणि S3 इज इक्वल टू S4. काय कारण आयसेंट्रॉपिक प्रोसेसेस, दोन्ही पण आयसेंट्रॉपिक एक्सपान्शन किंवा आयसेंट्रॉपिक प्रोसेसेस. ओके. S1 इज इक्वल टू S2 आणि S3 इज इक्वल टू S4. आता आपण हे सबस्टिट्यूट केलं तर काय होईल, इथं S2 ठिकाणी S1 आणि S3 ठिकाणी S4 लिहिलंय सगळ्यांनी, लिहिताय का माझ्याबरोबर, आर यू रायटिंग कम्प्लीट, राईटअप कम्प्लिटेड.
Yes, sir. Yes, sir.
ओके. तर आता इथं आपल्याला काय करणार, आता ह्याच्याऐवजी मी काय लिहिणार, आता राईटअप झाला तर कम्प्लीट, तर इथं काय होणार ला पण S1 म्हणणार मी. S3 ला पण काय म्हणणार? S4. म्हणजे इक्वेशन काय झालं आपलं? T1 इंटू ब्रॅकेट S1 मायनस S4 मायनस T2 इंटू ब्रॅकेट S1 मायनस S4 आणि इंटू T1 इंटू ब्रॅकेट S1 मायनस S4. हा T1 S1 मायनस S4 वी कॅन टेक कॉमन. ओके, ते कॉमन काढल्यानंतर काय होईल आपलं इक्वेशन? theta carnot is equal to theta carnot is equal to काय?
T1
T1
minus T2
minus
T1 minus
T2
divided by T1
इंटू
divided by T1.
म्हणजे आपण तरी पण एक स्टेप लिहूया आपल्याला लहान पोरांसाठी आपलं सगळं. S1 minus S4 divided by T1 into bracket S1 minus S4. S1 minus S4 will get cancelled. What we are getting now? T1 minus T2 divided by T1. जे आपल्याला कुठल्या इक्वेशन मध्ये पहिल्या चॅप्टर मध्ये आपण हे शिकलो. थीटा कार्नोट सायकलची एफिशियन्सी काय असते? फंक्शन ऑफ ओनली काय? विसरता अभ्यास करता is function of only temperature, not depends on working substance. ओके, तर काय दोन टेम्परेचर फक्त एफिशियन्सी कार्बनचे राहील अवलंबून राहते. कुठली? T1 म्हणजे हीट ऍडिशन टेम्परेचर आणि T2 म्हणजे हीट रिजेक्शन टेम्परेचर. एव्हरीबडी गॉट इट? एफिशियन्सी ऑफ कार्बन सायकल. ओके, ईटा कार्बन इज इक्वल टू इथे आपण आता वहीसाठी जाऊ शकतो. ओके, हीट सप्लाइड, हीट रिजेक्टेड आणि इथं आपल्याला काय सांगितलंय? 1 minus T1 minus T2 upon T1. हे लिहा मग लिमिट. Similar to Carnot cycle, Carnot vapor power cycle efficiency is function of two temperature, that is heat addition temperature T1 and heat rejection temperature T2. You already got it? Okay, now I will take atnos द्या. तुम्हाला जर काय चहा वगैरे घे काय, आता काय तुम्ही घरी चहा वगैरे पेट पेट अटेंड करता का ना? Today's date is 22/9/20 episode numbers. हा, रोल नंबर हे बाकीचे लिहितलेत हे करत करत वाटलं तुम्हाला मी. ओके, रोल नंबर 1 to 10 unmute. 1 is present.
Roll number 1 present, sir.
Roll number
Okay.
2 present,
2.
sir.
Roll number
Yes,
2
sir.
also. Roll number 1 present, 2 present, 3.
Yes, sir.
3 absent. 4 absent. 5.
Yes, sir.
Okay.
6, sir.
6 also
6
present.
present.
7 absent. 8 9 10 11 to 20. 11 present. Okay.
11 present.
12 13 14 15 16 17 18 present.
17 present.
Okay,
18 present, sir.
18 present. 19
Yes, sir.
19 Ajit present. Okay, 20
18 present, sir. 18.
18 present, 17 present, 18 present, 19 present, 20 absent. Okay, 21 to 30, 21 to 30, unmute. 21, 22,
Yes, sir. Yes, sir.
22, Suyak Dado present. 23, 24, 25, 20,
Yes, sir.
25 present. 26, 27, 28, 28, 29, 29, 29, 30,
30 present.
30 present.
Present, sir.
Okay, present, 30 present. Okay, 31, 32, 33, 34, 34,
34 present, sir.
okay, 35,
Present.
34
sir,
present,
35, yes, sir.
35. With 35? Okay, Shubham Singh.
Yes, sir.
36, okay, Shubham, I got it. Okay, 36, 37, present. Okay, 38, okay, Soham Orikar. 38, 39, 40,
40 present.
41, 40 present, Gaurav guided. 41,
41 present, sir.
okay, 42,
14 present. Present, sir. 42.
41 present, 42 present, Sujit Mane, okay, 43, 44, 45,
45 present.
okay, 45 present, which 45?
45.
Okay,
Six
okay,
are
okay. 46 present, 45 present, 46 absent, 47, 48, 49, 50, 51 to 60 unmute, 51, 52,
53 present.
53,
Yes, sir.
53 present, 54, 54, 55, 56, 57,
57 present, sir.
58, 57 present, 58,
Yes, sir. 58
59,
present.
okay,
58
58 present,
present.
59,
59 present, sir.
59 present, 60,
Present, sir.
60 also present, 60, who is 60? 60 absent, 61,
Sir, present 16.
61 present, Gaurav Karande, okay. Gaurav, going well?
Yes, sir.
Okay,
Well,
61, 62, 63, 64, 65, Kunal is there today?
Yes, sir.
Okay, 65 na? Okay, 66,
Yes.
65, 66, 67 present, 68,
Yes, sir.
67 also present, 67, okay, 68 absent, 69, 70, 71, 2, 3, 4, 5, 6, 77, 78, present I
Get present.
going well, Nikita.
Yes, sir.
Okay. Okay. Now we'll meet next lecture. Anybody PPT send करा सर कशाची सायनाथ ते ह्याची सायनाथ PPT का नोट्स okay so but take till that bye bye